Hello, in this video, we're going to be taking a look at some graphs, a series of graphs. One's the original, one's the first derivative, and one's the second, and we're trying to determine which one is which. Who is the original? So I've got these graphs, which one's which? What I want to be thinking about with this problem is just picking one and seeing if that makes sense. So let's choose this one as our original function. Now, this one is constantly increasing. If this thing is constantly increasing, then its derivative will just be a flat line that is positive. None of them are flat lines that are always positive, so that does not make sense. So then instead, let's take a look at this one and say, okay, well, this one is decreasing and then increasing. So if that thing's decreasing and then increasing, then its derivative should be negative and then positive. Well, hey, that's what that original one did. It was a negative value and then became positive. Okay, so then this would be this one's derivative. However, if we took the derivative of this, again, we'd have that same problem where its derivative should be a constant flat line. So that can't be the original either. So finally, we're left with this one. So does that make sense? If we check this area right here, we can see that this function is increasing on this whole interval until it hits this point. And so if it's increasing, that means that this thing should have a positive derivative. And hey, this one doesn't have a positive value, but this one is positive until this point. And then it has a point of inflection right here where it shifts from being concave down to being concave up. So its second derivative should shift from being positive on this interval and negative on this interval. And hey, that's what that straight line from the beginning is doing. Now it's a matter of like putting this into sentences. So what I wrote is the original function starts concave down and switches once to being concave up right here. So its second derivative is this linear function. The original function is also starting increasing and then becomes decreasing right here and then increases again. And this parabola is positive, then negative, and then positive on those same intervals. In this example, I can see these are both wobbling around in real crazy ways. But one thing I find interesting is that this one is always positive, and which kind of leads some interesting things. If this is the first derivative, that would mean that the original function is always going up. And both of these go up and down. So that can't be the first derivative. If it was the second derivative, that would mean that the original function was always concave up. And if you look at both of these curves, they've got areas where they're concave up and areas where they're concave down. That must mean, since it can't be the first derivative, can't be the second derivative, this must be the original function. So between these two, one of them is the derivative and one of them is the second derivative. So if I look right here, this thing is concave down on this interval. So I want one that is going to be negative on this interval. Now right here, this is going negative. This has got positive and negative here. But if I look at this dotted one, this is negative while this thing is doing that concave down thing. So this dashed one should be the second derivative. And this one, just by process of elimination, must be the first derivative. And it does pretty much work out. This thing is decreasing right here, and that's the point where this thing shifts to a negative value. And then before that point, we've got all these positive values on the area where it's increasing. Here I've typed up just like a quick version of what I did. So again, here I've just typed up a short version of what I've just said. So if you're looking for like kind of a summary of the things I was talking about, they're all right here for you to write down what you please or add any other bits of information. Because I didn't even talk about anything over here in the negative area, but it might be worth looking at. In this example, there's not much going on, but one thing that I'm looking at is right here. I know that this thin line must be the derivative of that bold line. I don't know uh, if this one is the original or the first derivative, but I know this one is the derivative of the thick line because here the thick line is switching from increasing to decreasing. So this must be the derivative of that one. Now, the only question is this the derivative of the solid line or related to the thick line? Um, right here, this thing is shifting from being negative to positive, and this one is shifting from being decreasing to increasing at this point. So this one, the dashed line, must be the derivative of the thin line, which is the derivative of the thick line. So this must be the original function. The thin line must be the first derivative, and the dashed line must be the second derivative. If we check if that makes sense in terms of concavity, this thing is concave down on this interval. So we are definitely concave down here, and then it probably is switching, but very subtly, to being concave up right here, which is why it shifts to being positive at that point. In case it's easier for you to see what I said rather than hear what I said, this is what I said for you to write down. It is how I am justifying, which is the original, the first derivative, and the second derivative. That's the end of our video on finding the original. You might have noticed that I used a different method in each one of those problems, just trying to show some different problem solving methods. The first one I just sort of guessed is just like, what if this was the original? Would that make sense? Yes or no? Otherwise, you might look for a unique feature, like something always being positive or something always being negative. Otherwise, you could also just try to make pairs and just trying to identify who is the derivative of who, and then trying to look at that third one and seeing how it relates to one of the other two. And that's it. I could have used guess and check on all three of those. I could have found unique features in all three of those, but it's just what method works best for the problem that you're looking at. Thanks for watching. Hopefully you took good notes on the things that I was talking about in this video. And yeah, goodbye.